implicants. So the part 2 indicates selection of prime implicants, the setup, optimizing the tabular method. That means we have already gone through the first part of our problem. Now we're going to try to optimize it. All right, so let's move on to our next part. So at first we're going to create a new table here. Okay, the table will look something like this. So the table will have some rows and columns. So what are we going to put in the rows and columns? So the mean terms which are given in the question, so here is the question I have written for your convenience. So the mean terms given in the question will be written as column values. That means we're gonna put them in the columns, and just so it gets better for our understanding, I have written them in sequential order. All right, so 1 4 6 7 8 9 10 11 and 15, these are the mean terms that were given in the question. And what will be written in the rows? Here you can see the prime implicants which we have just derived a few moments earlier. These prime implicants will be written as row values. All right, that's why we actually calculated our prime implicants. So the so for our table, the row values will be the prime implicants. You can write them in any order you like, and for columns you will write the mean terms given in the question. Okay, so just for convenience I have written them in sequential order. All right, so let's move on to our next task. So now we're going to put a specific symbol for each individual prime implicants. So the symbol is actually marked as X. Okay, we're gonna call it basically it's a cross sign. So basically it's a sign indicating cancel or something like that, but we're gonna call it X. All right, so we're going to put this symbol for all of those prime implicants, but not everywhere, for some specific positions. Okay, so for example, consider the first prime implicant over there, X prime Y prime Z. So X prime Y prime Z, this prime implicant was derived for the mean term pair of 1 9. So let me just move on to a few steps before. So you can see X prime Y prime Z was written for 1, 9 for this pair. All right, so this is what is written over here for the mean term pair of 1 9, X prime Y prime Z. So we'll put X in place of 1 and 9. All right, we'll put X in 1 and 9. Okay, so let's put this sign over there for 1 and 9. Okay, so we're gonna do the same thing for all of those other prime implicants. All of these prime implicants are actually derived for some of the pairs, right? So we're gonna put this sign for all of those prime implicants to their corresponding positions. So this is how our table will look like when you complete putting X in all necessary places. That means W prime X Z prime, this prime implicant was derived for 4 and 6, so that's why we have put this symbol at the position of 4 and 6. Let's say the last one, WX prime. So this prime implicant was derived for 8 9 10 11 pair. All right, so that's why we have put this symbol in the position of 8 9 10 and 11. All right, so this is how we're going to complete the first step of this table. Okay, so this is what our table will look like when we're done with all the placement of all possible symbols in this table. Okay, so this is what our table will look like after we complete putting all the X's in the necessary places. So let's move on to our next task. So our next task would be we're going to find out all of those columns which have only one X in them. All right, that means we're going to, there are different columns, 1 4 6 7 8 9 10 11 15. There are different columns definitely. So we are trying to find out those columns which have only one X in it. Okay, so we're going to find them and put a circle around that X. So let's see how we can do that. Say for example, you can see that these circled x's are the are actually those columns, are actually those places where we can see that there is only one x in that specific column. So let me just roll back. So this is the actual table, and I want to find all those columns which have single x in them. Alright, so you can see at the first column, this one numbered column here, so you can see that there is only one x throughout this whole column. That's why I'll put a circle around this x. Same goes for this fourth column. So let me just show you. So I have marked all of those x's which are currently staying just as the single one in that specific column. Okay, so I have put circle around them. So now what we will do, now we're going to put a straight line through the columns and rows where we marked those circles in the previous step. Alright, so I've already marked some x's, and now we're going to put a straight line through those marked places, both row wise and column wise, and we're also going to put a tick mark at the end of the column just to keep track. So let's see what I'm saying. So I can see all those marked places, so I'm going to put some straight lines over them. So in our case, those columns are basically 1, 4, 8 and 10. So let's see how the straight line looks like. Okay, so you can see that for the first column over here, for the first circled element over here, I have put a straight line through the column and also a straight line through the row. So we'll put straight lines through the columns and rows for those marked places, and when we're doing that, we'll also put a tick mark at the end of the column so that we can just keep track that this column is done. Alright, so we're gonna do the same thing for this x at column 4, and this x at column 8, and this x at column 10. Let's see. So you can see the fourth one is done, and now the 8th one is done, and now the 10th one is done. Okay, so the row was already cancelled out. The row was already cancelled out when we did the 8. That's why for the 10th one we just cancelled out the column. Okay, so this is how we're gonna do our first phase at this table. Alright, so let's see what we can do next. Okay, so another thing, you may ask that why we are actually putting straight lines over all those columns, why we are actually putting tick marks right underneath them. Okay, so our final target is to put straight lines through all the columns. Alright, let's see how we can actually do that, and to keep a track of what we are doing. That's why we are actually putting that tick marks, so that we can understand when we're done with all the columns. Okay, so let's move on to the next task. So right now we have only circled and cancelled out some of the x's, right? Some of the x's from this table. So for doing so, we have actually cancelled out some other x's indirectly. So let's see what I'm saying. So for example, when we actually cancelled this x over there at the fourth column, right over there. Alright, so when we actually marked this x and then we cancelled this whole column and this whole row, then we just cancelled out this x over here at column 6 indirectly. You can check this out. Let me just go back one step. So I actually just cancelled out this fourth column and this corresponding row. I did not touch this x over here at column 6, but since I just cancelled out this whole row, that's why this x over here got cancelled out indirectly. So that's what I'm talking about. Okay, so this x over here got cancelled out indirectly, and the same way this 9 over here, so sorry, this x over here at column 9 and this x over here at column 9 too, so both of them actually got cancelled out indirectly. Alright, we have not directly touched them, but they were cancelled out indirectly. and the same thing can be said for this one too. This one over here at column 11, so this was also cancelled out indirectly. So these are the x's. Okay, so these are the x's which were actually cancelled out indirectly. So now we're going to go to those x's and we're going to cancel their columns, only their columns. Okay, so we're going to put straight lines through those columns only. So for example, we're going to go to this place. This x was cancelled out indirectly, so we're going to put a straight line over there throughout the column. Remember to put straight line only through the column because the row was already done. Alright, there's nothing to cancel anymore, so you can just put a straight line throughout the column. So the same thing will be done for this 9th column, and the same thing will be done for this 11th column, because there were some x's which were actually cancelled out indirectly. Alright, so we just go to those places and we just put a straight line throughout those columns, and that's it. Since we put some straight lines over those columns, so we'll also put some tick marks underneath them so that we can keep track, and here it is. Okay, so as you can see that we have already put tick marks over most of the columns. Remember, our target is to cancel actually all the columns. So basically we need to reach a destination where we can see tick marks underneath all the columns. So we're actually going nearer to that destination. Okay, so there's still column 7 and 15 left, right? So till now what we have done, let me just give you a short review. So at first we found out the those columns which had only single x in them, and then we marked those x's. Here you can see the circled x's, and then we put straight lines throughout that column and then that row for all those positions. Okay, so we did that. Here it is marked in red, and after that, when we're done with that, then for that step we also see that there were some other x's which were indirectly cancelled out, like this one over there for 6, and this one over there at 9, or this one, or maybe this one here at 11. So these are the x's which were actually indirectly cancelled out for our previous step. So we go into those places and we just put a straight line over those columns. Okay, only the columns. So the green straight lines are actually indicating those. So till now we have done that. So even after following these two steps, column 7 and 15 still got untouched. We could not touch column 7 and 15. We could not do anything to the x's of column 7 and 15. So we need to cancel those columns too. So how can we actually do that? Okay, so in such cases, firstly we need to take a look at the x signs which remained untouched. That means in this case there are 2 x's in column 7 and there are 2 x's in column 15. These remained untouched, so we need to take a look at them. Alright, so now what we're trying to find is, we're trying to find such an x. Okay, we're trying to find such an x that if it is circled, then we'll be able to cancel out all other remaining x signs. Alright, so that means among those untouched x's, we need to find such an x for which if it is cancelled, if we can somehow circle it, then we'll be able to cancel out all other remaining x's. So there's a point to remember over here, that remember circled x means we can put a straight line on both row and column. Alright, so whenever we circle an x, we can definitely put a straight line through the column and the row. Alright, so both row wise and column wise. So that's what we're trying to find. We're trying to find such an x that if it is circled, then we can somehow cancel that x, including all the other remaining x's. Okay, so let's see how we can do that. So in our case, we can see that this These x over here at column 7 and these x over here at column 15, both of these x's actually match the condition what we're trying to do. Alright, so in this case such x can be this one or this one too. So for our example, let's just consider this one, the yellow sign one. So let's just consider this one. Let's see what happens. Okay, so I'm gonna put a circle around that since I consider this x. Okay, so since I put a circle around this x, now I can cancel this column and this row, right? So let's just cancel it. Yeah, I'm gonna consider this one, and now I'm gonna cancel the column and the row. Alright, so now we can see that column 15 is actually cancelled out too. Alright, so we'll put a tick mark underneath it. So now if you look carefully, you will see that since we cancelled out this column and this row, this black line here over here, so it actually helped us to eliminate this x indirectly. Alright, so this is what is written here. So look carefully, this x got cancelled out indirectly. So what do you actually do when an x gets cancelled out indirectly? You remember? Well, we actually put a straight line through that x throughout the column. Okay, only the column, remember. So let's do that. Since this x got cancelled out indirectly, so we're gonna put a straight line throughout this column only. Okay, so yeah, so we have put a straight line over this column, and since this column was cancelled out too, that's why you put a tick mark over there at the end of the 7th column. So all of our columns now got cancelled out, and we have reached our target, right? Because we want to reach this destination where all of our columns are cancelled out. So the same thing could also be done if we selected this x instead of this one. It will also have the same actual effect. Alright, you can actually check this out for yourself. So we're keeping this for you. Alright, but we have shown one possible way. Alright, so let me just answer some important questions what actually students ask in most of the cases. So what would happen if we didn't choose any of those x's? Alright, so what would happen if we choose say this one? Alright, what would happen if we chose this x over this or this one? Okay, so let me just show you the simulation. It will be much clearer in the simulation. So if we consider this x where my mouse cursor is, so then at first I would cancel the column and I would also cancel the row, but as you see, if I cancel this column and this row, then this definitely doesn't help these x's at column 7. Alright, so these still remained untouched. So that's why we actually can't select this one. That's why we had to find such an x for which all the other x's can be cancelled out. Alright, that's why we can't actually select this x over here. Okay, so that's why we didn't choose this one, and the same can be said for this one too. If we chose this x, then we would also have some type of similar issues. Okay, so there are some other questions too. What would happen if we don't get such an x that would help cancel out all the other x's? Alright, so in that case, the best we can do is to find an x which will help us to cancel out most of the remaining untouched x. That means our first target is to choose such an x which will help us eliminate all other x's. But if we can't find that by any way possible, then we're trying to find the x by which we can actually eliminate most of our x's. Alright, and what would happen if we cannot cancel out a column even after following all those possible rules? That means, what if we have followed all the possible ways, we have followed all the possible rules, but still we can't find any possible way to cancel out a column? Well, this is very unlikely, but if you ever get such a case, then you are going to circle the x found in that specific column and then cancel out that column. However, we can only do this if there is absolutely no other way to cancel out that column, meaning we have tried all other possible ways. So hope you understand. So these are some of the important questions that students ask during this lecture. Okay, now let's get back to our actual correct solution over here. Okay, so this is the solution we have actually calculated throughout this lecture. So now since our solution is almost done, so now is the time for our answer. So what would we get from this long problem over here? So since all the columns have been cancelled out, so we just need to find the answer now. So to get the answer, we need to follow a specific procedure. So we need to look at those circles over here and take out the corresponding prime implicants. That means as you see, there are different circles over here, right? There are some x's which are marked with circles. So we're going to look at those circles, and we're going to take the corresponding prime implicants from them. So let's see. For the first one over here, the prime implicant is x prime y prime z. So we're going to take this out, x prime y prime z. All right. So for the second one over here, we can see that it's w prime x z prime, and for the third one over here, we can see the prime implicant is x y z, and the fourth one, you can see that both of these x's are actually indicating to the same prime implicant. So w x prime. So what we'll do, we'll take those corresponding prime implicants out, and then we're going to put or sign among them. Okay, we're going to put plus sign among them. So basically our answer will look like, our final answer will look like something like this one. So at first x prime y prime z, then for the second circle we get w prime x z prime and put plus sign among them, between them, and then we get xyz for the third circle here, and for the final marked x's over here, we get wx prime. So here we'll write those prime implicants and we'll put plus sign among them. So this is the final answer we are getting: x prime y prime z plus w prime x z prime plus xyz plus wx prime. So this is the end of our tabulation problem, and this is the final answer we are getting. Thank you everyone.